So welcome everyone, if you're joining us today, and people who are watching on YouTube as well. So just a few house rules. Just to let you know, the session is being recorded. So that's been recorded in the cloud, and also it's being broadcast live on YouTube. So you will be able to watch this afterwards. And if you've any questions, please can you address them through the Q&A button that you'll find towards the bottom of your screen. And what we also ask as well is if you could save any questions to the end. By all means, post them in there, but we probably will not answer those until the end. So right, I think we'll get started. So I'm joined today by Depak Lal, who is a member of the Glasgow Observatory. And today, Depak is going to give us an overview of the observatory, and he's going to discuss the facilities that they have on offer to you as well. Depak's also joined by David Boone. He's behind the scenes a little bit like me today, and he's going to be looking after the questions as well, and he'll be assisting Depak in answering any questions that you may like to ask. So I'm going to disappear now, and without further ado, I will hand you over to Depak.
Thanks, Stephen. I'm just going to share my screen. I hope you can all see that. So my name's Depak Lal. I am the Business Development Manager for UK GEOS, and what we have is and I work for the British Geological Survey, and that's part of the Natural Environment Research Council and comes under UK Research and Innovation. And UKRI and the Natural Environment Research Council have funded our observatory in Glasgow to explore mine water heat abstraction and storage, and that's what I'm going to be talking about today. So let me just get that across to here, it'll be a bit easy for me. Sorry, can you still see that?
Hi, Depak. No, it's disappeared as that, Depak.
Let me just stop sharing screen and go to the other screen. Share screen. Can you see that?
Yep.
Okay. Thank you.
It might be worth maximizing the view because we can see the sub. That's better.
Okay. So move that across as well. Just give me a second. Right. So what are we going to talk about today? Why do we need a subsurface laboratory for mine water heat? Description of the Glasgow Observatory, the questions and challenges that can be addressed, and how and why access, how do we get access to the observatory? And of course, I'm sure you're quite familiar with the context. Decarbonising electricity is well underway, but the big challenge is decarbonising heat. And subsurface heat and abstraction and storage is a relatively new frontier. And of course, I'm sure you're familiar with the three documents on this slide: powering our net zero future, progress in reducing emissions, and the Scottish government document on update to the climate change plan. And these basically set out the context in terms of what we're trying to do. So in terms of the project's landscape, I'm going to start by talking about the two in Scotland, that Shettleston and Lumpinians. Shettleston and Lumpinians were built in the late 1990s, and they served perhaps 16 to 20 residential properties. And there were maintenance and perhaps some contractual problems, which meant that the supply of energy wasn't as reliable as it should be, and consumers lost faith with the system, and that led to closure. And there's a key message in there, which I'm going to come back to, and that's about consumer confidence. And then you can see also on this slide, there's Gateshead, Caphouse and Markham and their live schemes. And there are multiple other schemes that we're aware of that are on the drawing board. And what's one interesting fact I picked up is that some 25% of the UK population is within reasonable distance of a coal mine. And that's not surprising because people went to where the jobs were where the industrialization was, and industrialization required coal. But what the mines represent is an industrial legacy and a liability, which we're now turning into an asset. What we have is flooded mines, which are anthropogenic aquifers. So what we've got at Glasgow is an at-scale development and research facility. You can explore the resources available below ground, the market potential, develop supply chains, explore licensing and regulation, test and perfect technologies. We have an instrumented site for comprehensive environmental impact assessment. You can explore innovation systems, cost and risk reduction, and critically, it's a safe environment to do work. There are no customers connected to the site, so you're not going to have a customer screaming at you if you do some stress testing of the regime. And we do encourage knowledge sharing at the site. What you've got there at the bottom here are two photographs which I find interesting. I'm hoping you're going to find them interesting as well. And not all coal mines are the same. And on the left-hand side, you can see an excavated mine which used a stoop and room mining technique, where basically pillars of coal and rock were left behind, and in between these pillars, coal was extracted. And not very pleasant working conditions, people on their hands and knees extracting coal. And then on the right-hand side, you can see the long wall technique, where pit props were used to support the ceiling. And there's a much wider coal face, a much taller coal face to work at, and a much more pleasant environment for the miners. Just goes to show that different mines will have different regimes. So in terms of the observatory itself, what you can see here is a picture of the centre of Glasgow. I don't know whether you can see my cursor, but there's the city centre and the Commonwealth Games Village. And this is the River Clyde and the Cunningham Loop. And this is north, so you can orientate yourselves. And the key part of the site is here above the mine, sites 1, 2, and 3. And we have in purple the boreholes that are environmental monitoring boreholes. And the green ones are for water circulation. And the yellow one is for sensor testing. And we also have environmental monitoring at site 5 and also seismic monitoring at site 10. And side on, in terms of the area above the mine, what we've got is sites 1, 2, and 3. And again, in purple, we've got the environmental boreholes here, here, and here. And the water circulation boreholes here, 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 and here. And essentially, what we've got here is the Glasgow upper coal seam and the Glasgow main coal seam here. And by tapping the mine at these points, we can have different flow regimes through the mine with the water flowing between the different levels. So we can do different kinds of research at the site. In terms of the physical characteristics of the site, abandoned coal mine, an at-scale facility to do really high quality research. We're working through 2 levels of mine workings for water circulation. And in phase 1, we've got the subsurface infrastructure for heat abstraction and storage. And the assets in the subsurface relate to the boreholes, the surface research compounds, and environmental monitoring equipment. And then in phase 2, we've got the above surface infrastructure, which I'm going to come back to in a moment. But in terms of what we've got there at the moment, in phase 1, we have the sites 1, 2, 3, 5, and 10. We have 12 instrumented boreholes for subsurface investigation. 5 are wide diameter boreholes for the movement of water, 2 of which access the Glasgow main seam and 3 the Glasgow upper. We have 1 wide borehole for sensor testing. And then we have 5 environmental boreholes accessing various parts of the structure, including the superficials at the top. And there are 5 of those across all the sites. In terms of the borehole equipment, we have room-movable low-flow pumps, hydrological data loggers, measuring temperature, conductivity, pressure, salinity, and total dissolved solids. We have electrical resistive tomography, to facilitate cross-borehole time-lapse imaging of the geoelectrical properties. And we have fibre optic cables down the boreholes to measure distributed temperature sensing. And we also have some copper down those fibres so that we can inject heat into the ground and basically monitor the transfer of heat. And on the left-hand side here, you can see a picture of Site 1 before the top surface infrastructure goes in. And what you can see here is the 3 boreholes. And we also have sensing equipment. We have scanning lasers that will monitor CO2 and CH4 in the atmosphere. We have the electrical resistive tomography equipment here to measure the electrical resistance below ground. And we also have an INSAR ground reflector so that we can monitor ground movements. And of course, we'll be doing interesting experiments. So we do want to make sure that we are monitoring the environment for changes. And that's why this equipment is really important. And so phase 2, which is what we're currently going through the design and construction program for at the moment. Phase 2 will be ready in February 2022, so not very far away. And essentially what we're doing is connecting sites 1, 2, and 3 with insulated pipes for the movement of water and the circulation of water through the mine. We also have a heat sensor and a chiller, and these are designed to mimic heating and cooling loads. So we haven't got don't have a need for customers on the site to enable people to do various kinds of development work and research. As I said, that infrastructure should be ready within a matter of a few months. So in summary, 2 submersible down borehole pumps, 2 reinjection boreholes connected by sealed and insulated pipes, a heat center and a chiller, and temperature and flow monitoring equipment to monitor what's going on inside this phase 2 infrastructure. But we've also got something else, which is we have 3 heat exchangers in parallel in the infrastructure so that we can monitor how the heat transfer process goes from taking the heat out of the mine water into the rest of the system. We have a tube and a shell heat exchanger, a plate and frame heat exchanger, and a brazed plate heat exchanger. And that way researchers can explore the different technologies for heat exchange in terms of the experiments that they're running. Mine water, addressing the questions and challenges. So what's the investigation opportunity? Investigate the resource and environmental impact, heat and water transfer, geochemistry, geobiology, corrosion, fouling, geology, the impact of thermal cycling on the subsurface, thermal breakthrough, where basically you've saturated the ability to either inject heat or take heat out of the system, how long the system takes to recover from anything that you do, the pathways and impedance of fluid flow, seasonality, the impact of seasonality on the amount of energy in the system, environmental inputs and zoning. You can investigate sensors and measurement technology, heat and fluid transfer and mobility, chemical and biological issues and solutions, and not understating the social aspect. You can investigate non-science issues such as regulatory compliance, social issues, which is acceptance, risk perception, market dynamics, and choices made by consumers. These are critical because unless we get consumer acceptance, this way of heating people's homes is not going to get very far. So in terms of using the facilities, the way we position the observatory is as follows. The Environment Agency, Scottish Environmental Protection Agency, and the Natural Resources Wales Agency lead on environmental protection and water licenses, and BEI sets the policy. But we're into that phase now where we should be looking at the practical regulatory regime, and it's finally catching up with the market potential. And I think the Scottish Government's led in many ways in this area through the Heat Networks Bill. And the UK Government is engaging on regulatory regimes and zoning and regulatory control. And it's increasingly appearing like the Office of Gas and Electricity Markets will be the likely regulator, though I don't think Ofgem really rolls off the tongue in the same way. And there's a good reason for Ofgem doing this regulatory work, because they understand the energy market and they understand some of the key principles in terms of supplying energy to domestic consumers. Ofgem majors on security of energy supply to consumers and always has done. And consequently, development work in a live environment is a significant risk. And that's why one of our key messages for accessing the observatory is that we have a safe environment for development and testing. We don't have any customers connected to the site, so you can do interesting experiments and not have customers screaming at you about the loss of supply. Trying to do that on a live environment is going to be very hard. Indeed, I've had experiences in the past where I've tried to do experiments and research on live environments, and it was made abundantly clear to me that if I do anything to disrupt the supply of energy, then it would not be acceptable under any circumstances. So zero consumers at the site, no security supply risk. Consumer confidence is critical to success factor in distributed heat. And again, it goes back to the experience we had in Scotland of Lumphinians and Shettleston, that consumers eventually lost confidence in what was going on. And so it led to the shutdown of the system. And so we really do need a safe environment to do this work, and we've got to maintain consumer confidence. It's an instrumented research facility paid for by UKRI with a £9 million grant. And importantly, we are already accumulating data sets for environmental information on the site that's publicly available. We encourage people, wherever sensible and practical, to share whatever information that they gather from the research they do at the site with us, and so we can publish it. There can be moratoriums in terms of time before it's released, but also we do recognise that people will have commercial research that they want to do, and of course we would then, on a case-by-case basis, discuss what can and can't be put in the public domain. We do recognise that people will want to keep some of this information secret, but wherever practical, because we're a public body and we have a public funded research facility, wherever possible, we would like to put as much information in the public domain as we can. And so in terms of accessing the facilities, please get in touch with me or any of the other members of the team. We have a website and we have a brochure which gives a good overview of the site and what the facilities are at the site. And you can find that on our website, and the link is there for you to get to it. I am going to stop talking there and ask, are there any questions?
I think everyone's a little shy at the moment, Deepak.
Right. I'll stop sharing screen.
Anyone got any questions for Deepak? If you want to kindly pop them in the Q&A box, or you can even put them in the chat now if you like. I think, Deepak, you've got away with it. You've obviously informed people very well. There doesn't seem to be any questions coming up at all there, Deepak, for you.
We'll give people a moment, I think.
You're getting people. Oh, we've got one now from Robin. Hi, Robin. Do you want to pop it in the? You can pop it in the chat if you wish, Robin. Robin's one of our members, and he's on the council. There is a question from Gareth as well.
Great talk, thanks. Have you undertaken any heat injection tests, and if so, how did they respond? Dave, do you want to take that one?
Yeah, good question. So, as you explained, Deepak, the research observatory there has got the capability to, let's say, inject or extract and inject heat into the mine water system in two main ways. So you can either use a heat pump and chiller, or you can opt to use the fibre optic cables that Deepak mentioned, the active DTS cables with copper wire down. So you basically, that copper wire heats up when you put a voltage across it, so up by maybe 3 or 4 or 5 degrees, and then you can switch it off and so generate a heat pulse down the length of the cable, and then monitor with the fiber optic DTS cables that are sitting within it, and you can monitor the temperature very accurately to 0.01 degrees C every 25 centimeters along the cable down to about 85 meters in some of the wells. You can then monitor the heat dispersion and the advection that from your plume. The answer to Gareth's question is no one's done it yet. So the cables have been installed. We're just going through sort of commissioning phase at the moment. But I think as Deepak said, quite soon, certainly probably by the winter time, certainly by early next year, you'll be able to come along and use those parts of the system should you wish to.
There's a question here from Robin. Trying biggest barrier to mine water adoption in the UK has been the legal ownership. Yeah, it's a long-standing question, that because owning heat below ground is something that I don't think we've really properly investigated as a country in legal terms. And I know BEIS was having some presentations and webinars about that kind of issue about 3 or 4 weeks ago. And I think it's still work in progress, unless you know any different, Dave. It's an outstanding challenge.
Yeah, it's one that's going through. There's conversations going on, I think, at various levels in government at the moment around. I think this has been identified. BGS wrote a position paper about this 2 years ago now, saying who owns heat. We need to know. Developers need to know. We're fortunate we've got Gareth Farr who's the lead in heat and byproduct innovation at Coal Authority here today. Unfortunately, I don't think we can't let him talk, but I'm sure he will be able to give people an update maybe in the chat on Coal Authority's position on that. But I think the main message is it's an issue that has been raised. The EA and SEPA and NRW are aware of it. The Coal Authority are aware of it. The Clean Heat team in BEIS are aware of it. And, there are conversations going on to look at how we can sort of better manage heat fairly, sustainably into the future, and to, lower the boundaries in terms of shallow geothermal deployment in the UK. And this observatory will be, let's say, an enabler to have some of those conversations and actually produce some of the evidence that we need to know to answer some of those questions and sort of support policy development in that area.
There's another question from Robin Curtis. Also, geochemistry is a big consideration. Do you have base level information on the geochemistry of the observatory?
Yeah, I can answer that, or you can.
Yeah, you go for it.
Okay, so yes, we do. There has been at least a year's worth of what we call baseline geochemical data sampling gone on at the observatory, and all the data is actually online via the on the UK GEOS website, which I put a link to in the chat at the beginning. And Deepak had on his slide. If you just Google UK GEOS, it will come up with the website. So on there's lots of reports and data sets with all the geochemical baseline data in there. So water chemistry. So we have like a baseline of what the mine water chemistry is like. It actually turns out the mine water in that part of Glasgow, in that part of the coalfields, relatively clean for a mine water system. Perhaps cleaner. When I say clean, there's less iron in it than you might expect from like some of the Yorkshire coalfields and some South Wales, but I say it will vary, of course, across the country. And one of the interesting things will be as researchers come onto the site and start to move water around in the mine water system, you have the capability to monitor not only the temperatures and everything, but the chemistry as well, and how that impacts and oxidation and biofouling and things like that within the mine system and the boreholes. Gareth Farr's just provided a bit expanded answer to Robin's earlier question. So the Coal Authority have considered ownership of heat, but they do not own the heat as such, but they permit access to the workings. That's the current situation. The Environment Agency SEPA or NRW license and permit water abstractions. The Coal Authority does have a heat access agreement, but this doesn't sell the heat as such. So it's not a commodity you can sell right now in terms of ground heat. Waste heat, well, maybe you could sell that if you were producing waste heat from an industrial use. Yeah, so the Coal Authority really providing the access, if you like, for the purpose of recovering heat from the ground, and that's kind of the short answer. But I think everyone can. There'll be a lot more discussion about this in the following weeks and months and years, and I think everyone's working towards making it easier for everyone else to get in there and use the heat for their customers. It's a good low carbon form of heating and cooling.
I think that's the last of the questions, unless there's any more. Has anybody got any more late questions?
Just one more for you, Depak, just in the Q&A section, which is one I'm keen to know the answer to. It's from Richard. Do you welcome Ground Source Heat Pump Association guests to the facility to see the site firsthand and to discuss opportunities? Yes,
we do, but it's just at the moment it's a building site. I've had several requests from other people in other environments saying they'd like to visit, and we would welcome people to come and visit, but we'd have to pick and choose our time, because obviously for health and safety reasons we wouldn't want to get in the way of the people who are constructing the surface infrastructure in phase 2, which hopefully should be completed pretty soon.
Depak, am I right in thinking there is a video being made, a COVID-friendly way of visiting the site as just a quick intro? Is that right?
Yeah, that's right.
Like a tour of the site, and then but I think the first, if you're interested in visiting the site, of course, and using it, of course, the first point of contact, get hold of Depak.
Yeah.
And I think once COP26 is out the way, it will become easier too, because there's quite a lot of building work going on, and there may be visits from delegates from COP26. Obviously, the politicians are all getting quite excited about it as well, rightly so.
If our members want to drop me a line as well to say that you're interested, do so, please do so, and I'll pass them on to Depak.
Cooling.
Got one more.
There's another question from Robin. Cooling, what is the temperature in your shallowest level? In the deepest level, it's about 11.5, isn't it, Dave? I don't know what it's at the shallow level.
Yeah, it's at about 10 or 11. It's kind of what you'd expect. So 10 degrees, pretty good for cooling, free cooling. Perfect. The groundwater table is quite shallow. It's right next to the river, and the groundwater level, I think it's about 4 meters below ground level. And the site, there is a few meters of made ground on the site, so it's really quite shallow. And the shallow water table. So the wells are screened off in the mine water levels, the deeper wells, and then they're screened off in the quaternary deposits, sort of till and river deposits and glacier fluvial deposits in the shallower wells. So there's an opportunity to explore and monitor the shallow and the deeper kind of groundwater levels.
And the way it's configured is that we can move water through the levels. We can reroute the water through many of the boreholes, so that you can explore how the fluids move through the various levels in various different ways. So room for interesting experiments.
Yeah, we've actually, Robin, if you're interested, we've just, I put it in the chat for everyone. we just wrote a blog about the just summarizing the DTS data from the first kind of baseline period. So we've been monitoring some of the wells with the fibre optic cables, and so that gives you an impression of the baseline undisturbed ground temperatures at the site. So I've just put the link in there if you want to have a look at that and read that and get back to me or get back to the team with any specific questions you've got about that. And it demonstrates the capability of fibre optic cables in subsurface temperature sensing. Yeah, I must say that Robin's just got fibre optic cables. So we made the decision to, this is a research grade site again. So the reason we've selected to use fibre optic cables is it's the most kind of accurate way and the highest spatial resolution, temporal resolution and accuracy way of monitoring temperatures, in a volume of material like the ground. And the fibre optic cables we used are from Silixa, who specialize in kind of oil industry. So they're quite rugged fibre optic cables, perfect for grouting into behind the well casing. And so they go all the way down the holes, and they provide very high, resolution in terms of monitoring, 0.01 degree resolution, degree centigrade. So you can start to see things that you would never see if you just had a single pendant logger type one monitoring point dangled down a well. You'll be able to monitor the temperature change right down through the well every 25 centimeters, and that enables you to see whether there's incoming groundwater flow, might be colder or warmer depending on what you're up to in terms of pumping water around the system or hot water injection. You might be able to recognize and characterize kind of higher hydraulic conductivity zones. You might be able to use that to look at how the influence of fractures, maybe fault sections, fractures, mine workings on how the water's moving around and the kind of heat storage potential of the system. So it's going to give you an unprecedented tool in your toolbox, along with perhaps your more kind of standard ways of monitoring temperature and groundwater quality to play with in there. So it's trying to push the boundaries in terms of using all the let's say the state-of-the-art kind of technologies.
I think that's, unless there's any more questions, I think we're there. I think we're there, Stephen.
Right, no problem. Right, well, thank you very much, everyone, for coming along. Obviously, I can clearly see it was a great interest, and you're getting some thanks in the chat now as well. So thank you very much, everyone. If you haven't got your tickets for our conference, which is on the 22nd of October, I've got to get that right, please do so. They're still available, and you can find it on the Eventbrite. And if you search for the year of the heat pump, we will come up under there. It's going to be a fantastic day, definitely a fantastic day. So I'd like to thank David again, and certainly Depak for joining us, and yourselves for joining us today on this webinar. Thank you very much, everyone.
Thank you all.
Thanks, everyone.